Hi dear friends, once again welcome back to heat transfer class. In the last class, we were talking about the unsteady heat transfer or transient heat conduction. That means the temperature is varying with respect to time. Today also I will be continuing with the same concept, same topic, unsteady heat transfer. I am going to finish uh, unsteady heat transfer in today's lecture. So myself, Mohammed Rafi, one among the TEQIP faculty from Assam Engineering College. I'm basically from Kerala, but I have done my MTech from IIT Guwahati and BTech from College of Engineering Toronto. I hope you guys are having good time at home. So please take care of your health, whether it is your physical health as well as the mental health. Okay, so take all the precautions against this pandemic. Always wear face mask and use sanitizer and always focus on the social distancing whenever you are outside, and let's try to break the chain and bring back the normal life very soon. Anyway, in today's lecture I am going to continue with the same unsteady heat transfer concept. So this is an initiative by TEQIP faculty with the motto of let's crack the gate. So I hope you guys are getting benefited from this initiative, and please like this video, comment and your opinion, and also share with your friends for a better reach. So in the last classes, we are this is I'm just recalling whatever we have discussed till now, so that it will be much more easy to continue. So we have already talked about the modes of heat transfer. We have already covered the one dimensional heat conduction, all the theory and other problems, previous year questions, and then we came up with the resistance concept and comparing the electrical analogy, and now we are in the process of discussing unsteady heat conduction. Today I will be covering whole discussion regarding this topic, and today I am going to brief you about the Hales chart. Now we are already done with the fins. So we almost finished a major portion of HMT, and we are left with the little portion, that is heat transfer with the heat generation and also radiation convection. So okay, so guys, always prepare your equation book as per my lectures, and start solving as many questions from any sources available to you. Okay, now like I said, I'm just recalling whatever we have discussed in the last class. So we are talking about the lumped heat capacity analysis. What is lumped heat capacity analysis? It is when the body have a very less internal conductive resistance. Then the whole body will be attaining the same temperature. Right? There will not be any temperature variation within the body. That is the whole meaning of lumped heat capacity analysis. So when we can apply this thing, it can be applied only if the Biot number of the system is 0.1 or less than 0.1. Okay, so now we have defined how to find out the Biot number for different size and shape of the object. So it is HL divided by K of the solid. Okay, now this L is the characteristic length, which can be calculated by the ratio of volume divided by surface area. Okay, and there is another non-dimensional number that is called Fourier number. So Fourier number also, like I told in the last class, you are going to learn much more, like the application, the beauty of dimensional analysis in the upcoming lectures. But basically all these dimensionless numbers are defined as per our convenience to make our analysis much more easy. So now we are going to explore the applications of Biot number and Fourier number in the unsteady heat transfer. So we have defined or we have derived this expression for a temperature profile or temperature variation within a unsteady heat transfer problem. Okay, so the equation was coming out to be Ti minus T infinity divided by T minus T infinity e to the power tau divided by time constant. Okay, so we have done a couple of questions in the last class, and today also we are going to see some interesting previous year question as well as some probable question which we are expecting similar kind of question will be asked in the competitive exam, especially GATE. Okay, So this is the expression, and some of you may have some confusion why there is no negative sign, or in your degree time or your graduation time you might have studied there is some negative sign. So it is nothing but how you are taking this ratio. If you are taking t minus t infinity divided by ti minus t infinity, then there will be a negative sign of bi into fo. That means throughout this expression there will be a negative sign. But instead of taking T minus T infinity, I am considering Ti minus T infinity. That is the only difference. Okay, so as per you are taking the temperature ratio, there will be negative sign or there may not be negative sign. I hope it is clarified. Clear हो गया क्या आपको? Clear, right? Okay, let's move on. कैसे हो आप लोग? ठीक है ना? Okay. So this is all about the expression for temperature profile. So if you know the temperature profile by using any governing equation, you can find out the heat transfer rate as well. Right now, the temperature profile, the very important conclusion from the temperature profile is that if you know the temperature profile, you can see the temperature whether it is heating or cooling. The process is exponential. That means in the initial state there will be a drastic change in the temperature, but as the time passes there will be very less change. Okay, so this is very important whether you are employed, like in our day-to-day life we have discussed about the applications of unsteady or the occasions of unsteady heat transfer. So in this scenario you should, I hope you got the clear cut idea about the temperature variation. That means in the initial stage there will be a drastic change of temperature, but as the time passes there will not be much change in the temperature. Okay, so till now we were talking about lumped heat capacity analysis. That means whenever the temperature is changing we assume whole body the temperature is almost same. That means suppose I am considering my body myself, then my tip of the nose will have some temperature, the back side of my head may have some temperature, or other part of my body may have some different temperature in real life. But in lumped heat capacity analysis I am just trying to make an assumption, or I am just trying to make some assumption you can say. So in that assumption I consider there is no temperature variation within the body. So you can employ the lumped heat capacity analysis, you can derive that temperature profile expression. But like I said, in our day-to-day life it is not the criteria. Like in day-to-day life the unsteady heat transfer without the lumped heat capacity analysis is very much prevalent. So how to solve such kind of problem, that is our concern. So for that matter there are different methods. Like I said in the last class, all this real life situation you can solve in different way, whether it is an analytical method or in numerical method or in graphical method. All these applications are there, right? So there are different approach as per our convenience, as per the boundary condition you can choose it, and depends on how accurate value you are looking for. Okay, analytical method and numerical method got different applications, and there are other factors also. Like I said, you will be learning all those things in the higher study. Okay, so guys, prepare very well, and I hope you will get an opportunity to learn to explore this subject or any other subject in a very interesting way. So anyway, what I wanted to discuss here is that what will happen, how to approach any unsteady heat transfer problem where the Biot number is greater than 0.1. That means if the Biot number is greater than 0.1, or if the Biot number is not less than 0.1. So this is, you cannot conclude or you cannot use lumped heat capacity analysis, right? So this is another method, a graphical method which is proposed by Hazel. Okay, there are some other modification also. So in GATE exam point of view I am just giving you a brief discussion about all this chart. So basically there are three chart. First one is to determine the temperature at the center line of a body. So basically, there are three charts defined by this Euler, and which is there are three separate charts for three shape. One is a plain wall, another is a cylinder, another is a sphere. So for all these three shape, they have from the experimental observation, they have defined or they have prepared a chart which will be having x-axis, y-axis, and there will be some curves. And from this graphical method, the beauty is that you can directly get the value, depends on the scenario. So in order to find out the temperature at the center line, they have prepared one chart, and it look like this for a case of a infinite long cylinder. Okay, I am just briefly talking about all these things. So this is the temperature variation, and there is a Fourier number on the x-axis, and there is these curves are representing 1 by Biot number. So how this is defined and all those things, it is not in our discussion. We are not concerned about all those things. As a gate exam point of view, you should have a brief idea what is a Euler chart and what is application, and if at all it is asked in a theory question, you should be able to answer it properly. Okay, so this is about the first chart. Another one is a just like first chart is to determine the temperature at the center line, then the another chart, second chart is for determining the temperature at the other parts of the body, right? So there is, instead of drawing all those things in a single chart, they have defined the x-axis y-axis coordinate for another chart, and they have plotted some curves, and from which you can directly find out what will be the temperature at different points of the body. So similarly, if you know the temperature, our main objective is finding out the heat transfer rate. So there is another chart, the third chart, which will help you to find out the total heat transfer rate up to a particular time constant t. Okay, so basically there are, like what I am saying, there are three charts. One is showing the temperature at the center line, another is showing the temperature distribution, another is showing the total heat transfer rate, and there are three charts for three shape. One is a plain wall, another is a cylinder, another is a sphere. Okay, so this is all about the Euler chart. So but for a Euler chart there are some limitation also. The first point is that the body must be in a uniform temperature initially. That may not be possible in our real life situation. Okay, so Euler chart, it is prepared based on some assumption, right? So the first assumption was the body was in a uniform temperature. So if it is not like that, then you cannot use Euler chart for the problem solving. Similarly, the temperature of the surrounding as well as the H value should be constant and uniform. That is also, we know that H is not a thermophysical property, so it will be varying, depends on the scenario. So in our application, if it is changing, then also you cannot take help from the Euler chart. So similarly, another one is there should not have any heat generation also. Okay, so these all are about the advantages as well as the limitation of Euler chart. So now I am going to solve a couple more questions, and I will be winding up the unsteady heat transfer problem. Okay, so get ready to solve the problem. So guys, like I said, whenever you are coming across problem solving session, please pause the video and practice yourself. And if you are getting the right answer, please comment on the live chat section. And if you are getting a wrong answer also, please identify your mistake and rectify. Okay, so let's move on. So everybody, please solve it. So let's try to solve it. Are you able to follow it? Are you ready? Yes, let's try to solve. So this is a very straightforward question. All the parameters is given, and the body. I told you in unsteady heat transfer there will be three temperature, Ti and T at some particular scenario, and surrounding temperature. So initially the body, the carbon bolt initially at 150 degree Celsius. So it is 150, and it is dropped into an oil bath. So the surrounding temperature is going to be 20 degree Celsius, and we have been asked to find out the final temperature after a time period of 3 minutes, right? So 3 minutes means 3 into 60, 180 second. And the diameter of the ball is given. D is 5 centimeter or 0.05 meter. So all the parameter is given. So let's try to solve. So like I said, if you are taking Ti minus T infinity divided by T minus T infinity, then the equation will be root of minus will not be there. Sorry, HA by rho VCP into T. So all these parameters are already given. So let me substitute this value. Ti is 150 minus 20 divided by T minus 20 equal to e to the power h value is 450. A by v in case of a ball. So a by v 4 pi r square divided by 4 by 3 pi r cube, right? So in case of a cylinder sphere, it should be a by v will be equal to 3 by r. So I am just substituting 3 divided by r is 2.5 into 10 to the power minus 2, and density कितनी होती है भाई 7830, right? 7830, and Cp value is 434. So if I am substituting this value directly, I can write it is going to be T minus 20 equal to 7.44. That means temperature is equal to 27.44 degrees Celsius. So option number is A, Assam. Are you able to follow? Okay. So this is the solution. So let's move on to the next question. So everybody read the question thoroughly. So this is look like a lengthy question, but you should not be confused. If you know the concept, it is very easy to solve. So there are equal amount of liquid metal at the same temperature are poured into 3 molds made of. There are 3 molds made of copper, steel, and aluminum. So the shape is given. The size of the molds are such that the outside temperature of the mold do not increase appreciably beyond the during the solidification. That means there is no much heat transfer outward. Whatever mold material is float, there will be some heat transfer. So here the question is क्या पूछा गया क्या है the sequence of solidification, मतलब how fast the heat transfer is going to taking place. So here it is a question related to the thermal diffusivity, right? So we already know the solidification time. You can say a solidification time, the time taken to solidify will be inversely proportional to the diffusivity, because if the temperature diffuse very fast, then it will be solidifying very slowly. Okay, so मतलब diffuse नहीं करना है ना, solidification should taking place if it don't diffuse within the body. Okay, so if you can find out the diffusion equation alpha equal to k by rho Cp. So what is the alpha in case of copper? Alpha copper equal to k by rho Cp. How much you are getting? K value. All this data is given 40 divided by 8933 into 385, right? 401 385 and 8933. Similarly, what about the steel? Alpha steel equal to 60A, this much. Okay, 60.578 alpha rho Cp, right? 7854 into 434. So if you calculate like this, alpha aluminum, all this value is coming out to be steel will be 17.7. I just calculated using my calculator. So you also just verify my answer if you are getting the right answer or not. So it is coming out to be 17.6. Another one is 116. Just check whether you are getting the right answer by using your calculator. Okay, gate calculator. So from this you can easily draw the conclusion is that alpha copper is much greater than alpha aluminum, much greater than alpha steel. So what will be the ratio or the sequence fastest to slowest? If alpha copper is higher, it will be the slowest. Okay, so fastest to slowest will be, so it is 97.2, 17.7, 116. So copper got the maximum value. So it will be solidifying very fast, right? Then aluminum, then steel. So the answer is option number C. Okay. So let's move on to the next question, which is also a similar question, whatever we have discussed in the previous slides. So let's try to solve it. So in this question, a steel ball, similar to the previous case, is a sphere initially in thermal equilibrium. So let's try to identify what are the Ti, what are the T infinity, what is the T value. So initially it is in 1030 degree Celsius in a furnace cooled in ambient air to 30 degree Celsius, and with the convective heat transfer coefficient is given, H value is given, rho value is given, K value is given, specific heat capacity is given, all the parameters are whichever required to solve this question is given, and the question is what is the time required for to reach this body for 30 degree Celsius. So if I am writing the Ti minus T infinity divided by T minus T infinity equal to e to the power HA by rho VCP into T. So this is very important equation. Guys, please remember this thing and be familiar with the parameters. Okay, so that you will be, at least you will find one question in any competitive exam and you will be able to solve it correctly. That is why I am again and again solving similar kind of question. So let's try to 1030 minus 30 divided by 430 minus 30 into e to the power h value is 20 into it will be 3 by r, right? R value is 30 into 10 to the power minus 3. Density is 7800. Rho CP is 600. So and the time. So if I am just taking logarithm on both sides, I will be able to get what is the answer. If you am writing like this, then you can write it is logarithm of 1000 divided by 400, right? Equal to logarithm of some value 4.27 into 10 to the power minus 4t, just like that. So it will be coming out to be, T will be coming out to be 2144.12 second. So you will be getting an answer. Option number Delhi, right? You got the answer. Please, if you are getting the right answer, please comment on the live chat, and if you are getting a wrong answer, please don't worry. Please go through the way I was solving, and even if you need not to do always use this expression, you can either use this is equal to e to the power bi into fo also. But I am just using as per my convenience. So you also use as per your convenience. You should not be restricted to be using the same method to get the right answer. You will get the same answer even if you follow any other approach as well. So let's move on to the next question. So this is also a question asked in GATE 2005. So let's try to solve it. You also please try how to solve it. So similarly, it is again a copper ball and diameter is given Ti. I told you we have to identify three temperature: Ti, T infinity, and T. So Ti drop a diameter at a copper ball. Yes, initially it was at 500 Kelvin. Dropped into oil bath whose temperature T infinity is 300 Kelvin. Thermal conductivity of the copper, all these parameter K value, density, right, and specific heat capacity and convective transformation, and it is directly mentioned lumped heat capacity is valid. The rate of fall of temperature of the bowl at the beginning. So this is a quite interesting. You are going to find out what is the expression for T, right? So we already know T I minus T infinity divided by T minus T infinity equal to e to the power H A divided by rho VCP into T. So if I am just substituting this value, Ti is 500. You can either take in Kelvin or degree Celsius because we are talking about the temperature difference. So it will not make any difference. Okay, that is why I am not bothered whether it is in degree or Kelvin. Both will have the same meaning. So 500 minus 300 divided by T minus 300. We don't know what is T value. Substitute e to the power. H value is how much? H value, H value, H value. Yes, 250 into, again it is a copper bowl, so you can say 2.5 3 by r, 3 by 2.5 into 10 to the power minus 3 into rho value. How much? Density is 900, right? 9000, and Cp value is 385. So if I am substituting this value, I should get a temperature expression T equal to something like this, 200 e to the power minus 0.0865 T. Okay, T minus 300 will be coming out to be like, or plus 300. So the question is not the temperature, it is asking about the rate of fall of temperature. So at the beginning, so rate of change of temperature, that is dt by T. So it should be 200 into 0.0865 minus, right? So differential of this thing is e to the power of this thing, and I am asked to find out 300 differential of thing become 0. I am asked to find out the rate of change fall of temperature at a time equal to 0. So if I am substituting 0, this is going to be e to the power 0 or minus 0, it is going to be 1 value. So basically our rate of change will be like this, 200 into 0.085. So it is going to be minus 17.3. So what is this meaning minus? It is just a rate of uh, fall of temperature. That means the temperature is going down. Okay, there is no any other meaning for that negative sign. It is just showing the direction of heat transfer. Okay, so let's move on to the similar kind of question. Let's try to solve it. So everybody please try to solve. A cylindrical steel rod, diameter length दिया गया है. Yeah, this is also Ti, T infinity and T. What are these temperatures? So Ti is 750 degrees Celsius, then immersed in a water bath at 100 degrees Celsius. So it is 100 degrees Celsius, and the rod is reaching a temperature 300, right? So here directly it is asking about the time. So let's move on how to solve this. So here you can see there is a cylinder having a length of 0.2 meter and diameter of 0.01. So a by b, what will be the a by b? This is quite interesting. Here you have to consider the area, end face area also, otherwise you will not get the right answer. So it will be pi d square by 4 into 2 plus pi d into L divided by volume will be pi d square by 4 into L. Okay, so if I am just trying to solve it, I will get pi d will be getting cancelled everywhere. So d by 2 plus L divided by d square क्या होगा, d pi d is getting cancelled, right? dl by 4. So if I am substituting this value d equal to 0.01 divided by 2 plus 0.2 divided by 0.2 into 0.01 divided by 4. So what is this value you are getting? A by b you will be getting around some value. I am not bothering about this thing. So if I am just using the expression ti minus t infinity divided by t minus t infinity e to the power ha by rho vcp into t. So here the concern is t, all other parameters is given, all this thing is given. So if I solve this question, I will get time equal to exactly 42.43 seconds. Okay, so this question could have been asked as a numerical type question, or they could have asked by giving the option also. So at any cost you should not get any other answer, you should get the right answer if you follow the same procedure. Okay, so like guys, please don't get confused how when we are considering the length. If the length and diameter is a comparable entity, then you have to consider the end face also. If it is an infinite long length, then you can ignore the end face area, because it will not be the area on the end will not be that much relevant. If I am adding 100 plus 1, it will be 100.1, but if I am adding 10,000 plus 1, so that difference will be there, right? So let's move on to the next slide. So this is also a very interesting question. Everybody please read the question thoroughly. So what is the question here? Two cylinder shaft A and B at the same initial temperature simultaneously placed in a furnace. The surface of the remaining gas temperature at all after they are introduced into the furnace. The temperature variation in the axial direction of the shaft can be assumed to be negligible. Data is given. The temperature at the center line of the shaft reaches 400 after 2 hours. So if I am talking about the Ti minus T infinity, or the temperatures Ti, T infinity and T. So for A and B, what is the condition for A and B? For A and B, Ti, T infinity and T, all are same. Guys, all are same. So the directly they are asking about the time required for the center line of the shaft to attain 400 degree Celsius. So they have already mentioned the time required for A is 2 hours. So what is the time required for B, which is having the same parameter, but they have some differences in the dimension as well as the thermal conductivity and the volumetric heat capacity. So in this is a special type of question. So for this type of question, we have to focus on, like, if you calculate the Biot number, it will not be less than 0.1. So this is a special type of question which you have to use Taylor chart, or you have to approach this thing in a different way. You should not apply the lumped heat capacity analysis in this question because it is not falling under the category of 0.1. Okay, so here this is a special type of question. So if you just go through the question and if you can find out the Biot number, then you can equate the Biot number, or you can find out the Fourier number, then you can equate the Fourier number. And if since the temperature ratio is same, so if you can equate the error in the expression and all those things. So in GATE 2016, there were two questions, one related to the unsteady heat transfer, which is not falling under the category of lumped heat capacity analysis. So this question I am going to compare Fourier number of A should be equal to Fourier number of B. That is the main concept you have to remember while solving similar kind of question. So what is the Fourier number? We already know Fourier number is equal to alpha t divided by L square. Okay, so alpha is equal to, Fourier number is like this, alpha equal to k by rho cp into t divided by lc square. Okay, so if I am going to solve this thing by substituting FOA equal to FOB, then I will be getting a k value of A is 40 by rho cp of k is volumetric, right? 2 into 10 to the power 6. And LC, in case of a cylinder, in case of a long cylinder, if you don't know the length, then you have to consider it as a long cylinder. In that case, we already know it will be LC equal to R by 2, or you can see diameter also you can directly take as it. Okay, so if I am just taking tau value for the first cylinder is 2 hours, so 2 into 60 into 60 divided by LC is equal to 0.4 square. So if I am substituting this value 20 into T, I don't know, then 2 into 10 to the power 7 into 0.1 square. So if I am solving this, you should get a T equal to 9,000 second. That means equal to 2.5 hours. So shaft A took 2 hours to reach it, but shaft B will be taking a 2.5 hours. Okay, I hope it is clear to everyone. So let's move on to the next question. So this is also GATE 2016 set number 1 question with a 2 mark. So it is very straightforward question, just like the previous case. So let's try to solve it by finding out Ti equal to T infinity equal to T value. So what is the value? If a steel ball 10 mm diameter, we have been familiar with similar question for a very long time. So it is 1000 K to be cooled to 350 K by immersing in a 300 K ambience. Okay, so the convective transfer coefficient, all this thing is given. I am directly going to apply Ti minus T infinity divided by T minus T infinity e to the power HA by rho VCP into T. So what is the Ti minus T infinity? Yeah, jaldi karo. Ti minus T infinity is 300. So everybody please practice all this question. I know this was a kind of a repetition, similar questions were repeating every time, but just realize the importance of these expressions. Okay, so in unsteady heat transfer you can expect at least one question in any GATE or any competitive exam, but you should not miss that mark. That is why again I am reminding you to remember this expression and to be familiar with this expression when and where I am using LC, or how I am finding out the characteristic length, all those things. Okay, so rho value density is equal to how much by सॉरी मैंने गलत किया है. ये क्वेश्चन में ये सब डाटा नहीं दिया है, डायरेक्टली दे हैव गिवन द टाइम कांस्टेंट, सो आई कैन राइट टी बाय टी सी, राइट. सो द क्वेश्चन फिर से पढ़ो. द टाइम कांस्टेंट for the cooling process is 16 second. Okay, so it is directly given as a 16 second, the time required to reach the final temperature. So I can write e to the power t by 16. Okay, so if I am just writing, it is 700 divided by 50 equal to e to the power t by 16. So if I am just doing the calculation, it will be 5. So it can be, the time required will be, directly you can say it will be 42.23 seconds. Okay, so this is all about this question, which was given a time constant, and you can directly find out the time required to reach the final temperature. It was a question asked in GATE 2016 with a 2 mark. So if you just remember this expression, you could have uh, scored the full mark. So this is I know it was a short lecture, and I was not discussing any much more, not very long or very conceptual thing, and I was just adding on a little more theory which we have already studied in the previous class. So everybody please watch the previous classes and prepare your own equation book, practice as many questions, and let me know if you are finding any problem. And if you find this video is interesting, or if it is beneficial, please like, comment and share with your friends. So until then, in the next class we will meet with the steady state heat conduction with the heat generation. After this class, after discussion of the next class, I will be sharing the PPT which is covering all the slides whatever I have shown in front of you. So please, but that is not sufficient. Don't wait for the PPT, because that will not help you. If you prepare your own equation book, definitely it is going to help you throughout your engineering career. So please prepare your equation book as per your convenience, as per your design, whether it is in mother tongue or any language. It should be your personal asset. Okay, so for my PPT you can take as a reference for preparing your equation book, but for exam point of view, whenever you are going to attend any competitive exam, please revise your equation book, and whenever you are practicing practice questions, then also you can take help from the equation book. So next class we are going to talk about the steady heat transfer with heat generation. Until then, have a nice day. Thank you.